Alright, welcome to the video on metabolism. So after we absorb all those nutrients from the digestive system, we turn it into energy, and we can see skeletal muscle uses the most energy, followed closely by the liver and the brain. The kidneys and the heart also use a lot, and then other organs use up the rest. So first we need to define metabolism. So it's the chemical processes occurring in cells that transform nutrients into energy or into materials the body can use or store, or a more generic definition would be just all the chemical reactions in the body. A calorie is defined as the amount of heat needed to raise the temperature of 1 gram of water by 1 degree Celsius. And we use that to measure how much energy is in food. Then the basal metabolic rate is the amount of energy the body needs at rest. So like while you're sleeping, you still use some energy. Your heart is beating, you're breathing, that takes energy. And the factors that affect it, first is body size and composition. So if you're bigger or have more muscle, your basal metabolic rate is going to be higher. Another factor affecting it is gender. So males tend to have more muscle mass, so theirs is generally higher. And then age. The older you get, your muscle mass starts to decline, and that slows down your metabolic rate and your basal metabolic rate. Alright, we're going to look a little bit at hunger and satiety. So we need to know the effect of these hormones on the appetite. So leptin suppresses the appetite. Peptide YY signals satiety, so tells you you're full. Ghrelin produces hunger. Insulin suppresses the appetite, and then cholecystokinin, or CCK for short, suppresses the appetite. So which hormone stimulates the appetite? The only one on this list that stimulates the appetite is ghrelin. Alright, nutrients are usable food components that supply the body with chemicals necessary for energy. The macronutrients are carbohydrates, lipids, protein, and water. The micronutrients are vitamins and minerals. Essential nutrients are obtained through the diet. They have to be obtained through the diet. Non-essential nutrients can be synthesized by the body. So carbohydrates are the body's primary energy source. That's their function. They exist as monosaccharides, which are simple sugars like glucose. Those can be absorbed without being broken down. Disaccharides have to be broken down before they're absorbed. Polysaccharides are these long, complex carbohydrate chains, and most of our diet should contain them because they contain other vital nutrients, and also they're absorbed more slowly, so that prevents like spikes in blood sugar like you might get when you eat a candy bar or something. You want to keep your blood sugar level if possible. Then cellulose is technically a carbohydrate, but our body can't digest it. We call it fiber, and so we need it to add bulk to the stool. Without that, it's hard to get rid of the waste from your digestive system. And in the gut, bacteria, it produces what are called short-chain fatty acids, and these help protect the intestinal lining and promote the growth of good gut bacteria, and they also lessen the risk for certain metabolic and immune disorders. So even though our body doesn't directly use fiber for energy, it is an important nutrient, or cellulose, sorry. Alright, next we need to know functions of lipids. They can act as a reservoir of excess energy. They're the best way to store energy. They enable absorption of certain vitamins, which we'll talk about. They contribute to the cellular structure. Phospholipids make the cell membrane. They also insulate and protect the body. And each gram of fat contains about 9 calories per gram compared to only 4 calories per gram for carbohydrates, so fats have a lot more energy. Trans fats increase the risk for heart attack and stroke. These are typically found in commercial baked goods and snack foods, so you want to limit your consumption of them. Alright, proteins do a lot of work in the body. They are a major component of the cell membranes. They make up most of the structure of bones, skin, hair, nails, tendons, and ligaments. Antibodies, hormones, hemoglobin, and enzymes are all proteins. And complete proteins are going to be able to supply all the essential amino acids, and these typically come from animal sources. Incomplete proteins are going to lack one or more essential amino acids, and these typically come from plants. And essential amino acids are essential because the body cannot synthesize them, so they must be obtained through the food. Vitamins are mostly they function as coenzymes, which support enzymes in metabolic processes. Most of them are water soluble, so they can be absorbed with water, and they're excreted by the kidneys, so you have to consume those every day. The fat soluble vitamins are A, D, E, and K, and we need fat to absorb these. These can be stored in the body. Minerals are needed for numerous vital functions such as nerve conduction, brain function, muscle contraction, red blood cell formation. So they're important also. So non-essential amino acids are and the correct answer is B. They're synthesized by the body, so we don't need to get them from our diet. It's not that they're not essential, it's just that we don't need to eat them. They are essential. Alright, metabolism, just to review, consists of catabolism, which is breaking down complex substances into simpler ones or into energy, and then anabolism is forming complex substances out of simpler ones. So those are the two broad categories of metabolism. Now we're going to talk about metabolism of certain nutrients. So start with carbohydrates. All ingested carbohydrates are converted into glucose, most of which is immediately burned as energy. Glucose can also be stored as glycogen or converted to lipids. And the primary goal of glucose catabolism is to generate ATP, which other cells use for energy. So the three phases of the three phases of carbohydrate metabolism are first glycolysis, then anaerobic fermentation, and then aerobic respiration. So we'll look at each of those briefly. In glycolysis, the glucose is broken down into pyruvic acid. This does not require oxygen and produces some ATP. So again, it occurs without oxygen. You take one glucose and break it into 2 molecules of pyruvic acid, but just gives us a little tiny bit of energy. Anaerobic fermentation, or sometimes it's called anaerobic respiration. In this occurs when there's not enough oxygen, and pyruvic acid will be converted into lactic acid. This lactic acid is stored in the liver and converted back to pyruvic acid when oxygen becomes available. And then that pyruvic acid will enter aerobic respiration. So in aerobic respiration, this is what happens when oxygen is available. So pyruvic acid will enter the mitochondria and it's converted into acetyl-CoA, which enters the citric acid cycle and then the electron transport chain. The end result of these reactions is carbon dioxide, water, and large amounts of energy. Alright, for this body at work, we need to define the following mechanisms that the body uses to maintain a consistent level of glucose in the blood. So, glycogenesis, when there's abundant levels of glucose, it's converted to glycogen and stored in the liver. Glycolysis, when the blood glucose levels fall, this glycogen will be broken down into glucose and then released into the blood. And then gluconeogenesis, so if necessary, the body can create glucose from fats or amino acids. So all ingested carbohydrates are converted to, and the correct answer is glucose. Alright, next is lipid metabolism. And again, this produces more than twice as much energy as the breakdown of carbohydrates. When needed for energy, fat molecules stored in adipose tissue are hydrolyzed into glycerol and 3 molecules of fatty acid. Glycerol enters the glycolysis pathway where it gives us a little bit of energy. The fatty acids are converted into acetyl-CoA. Acetyl-CoA then proceeds through the citric acid cycle and the electron transport chain to yield large amounts of energy. And so acetyl-CoA is a 2-carbon fragment, and a fatty acid chain could be 30 or 40 or carbons long. So you can get maybe 20 acetyl-CoAs from each fatty acid. So that's why we get a lot of energy from fats. Alright, protein metabolism. Generally we use protein to build tissue. We can use it for energy if we're starving, but it's not very common. Next we're going to talk about thermoregulation. So our body temperature normally fluctuates. Most of the body's heat comes from chemical reactions of metabolism. So all those reactions we just talked about, glycolysis, the citric acid cycle, the electron transport chain, heat's a byproduct, and that makes us warm. To get rid of this heat, there are 3 methods. Radiation is transfer of heat through the air, so heat just moves to the air, and we're generally warmer than the air around us, so we lose heat that way. Conduction is the transfer of heat between 2 materials that touch each other. So if we touch something cold, such as our clothes, we lose heat that way. This is the reason why if you sit in a chair that somebody was sitting in, it's usually warm because they lose heat to the chair. And then evaporation uses heat to change water into a gas, so that's like when we're sweating. That's a good way to cool the body because that takes a lot of heat to change that water into a gas. Next we need to describe the process of negative feedback that helps regulate body temperature. So if the body temperature rises, the blood vessels will dilate. This is the blood vessels going to the skin. That will cause more heat to be lost through the skin, and also evaporation of sweat cools down the body, so that will bring our body temperature back to normal. If the body temperature falls below normal, the blood vessels going to the skin will constrict, so we'll lose less heat that way. The warm blood stays deep in the body. Also, we'll start to shiver. That will produce heat and get our temperature back to normal. So proteins are primarily used to, and the correct answer is build tissue. I'm going to finish with some heat disorders. So heat cramps are painful muscle spasms resulting from an excessive loss of electrolytes through sweat, usually after strenuous exercise. So just make sure you drink enough. Heat exhaustion may develop after prolonged exposure to high temperatures without adequate fluid replacement. Symptoms include dizziness, headache, muscle cramps, nausea or vomiting, and fainting. People prone to heat exhaustion include the elderly, people with high blood pressure, and people working or exercising in a hot environment. And then a level up from heat exhaustion is heat stroke. This is a life-threatening condition that occurs when the body's temperature reaches 104 degrees Fahrenheit, which is 40 degrees Celsius or higher. Can be caused by high environmental temperatures or strenuous physical activity, or usually it's a combination of the two. This requires immediate medical attention to avoid brain damage, organ failure, or death. Symptoms include hot, dry, flushed skin, headache, rapid heart rate, and muscle cramps or weakness. Seizures, hallucinations, or unconsciousness may also occur. And then if our temperature gets too low, we may get hypothermia. That's when the body's temperature falls to less than 95 degrees Fahrenheit or 35 degrees Celsius. Typically caused by exposure to cold weather or immersion in cold water. Symptoms include shivering, lack of coordination, slurred speech, confusion, and drowsiness. The confusion is what keeps you from being aware that you're freezing. And if the body temperature drops less than 90 degrees Fahrenheit, death usually occurs.